Hi, so I'm Rafal, and I'm an engineer at Spotify, and I've been working for Spotify for about 2.5 years now. At the same team actually, and that's pretty cool. But first a little bit about the Hadoop, so the thing that I work with every day. So we have pretty big Hadoop cluster. We have YARN cluster, which is a pretty generic one, makes a generic cluster. We have 1,800 nodes, soon to be more than 2,000. That is relative, about like 70 petabytes of storage, 80 terabytes of memory. There's 40-something thousand CPUs in there. Blah blah. About 1 petabyte per week. It's pretty cool. 40,000 jobs per day. And you can ask me any questions at the end of the talk about Hadoop. But today I'm not going to talk about Hadoop, well, not directly. We're going to talk about data notebooks. And this is the agenda. So first we're going to talk about the history. So how come we're talking about this thing called data notebooks? How is it possible that we can do these things? Then we'll use up at the use case of notebooks. So what is the use case, why people need it, why people want it, and how do they use it? Third thing is going to be the options. So what are the options right now available for you that you can start using today? And we'll finish strong with the demo. Maybe we'll see if it works. But first, if I say data notebook, does it mean anything to you? Like if you understand or if you have any thoughts about it, please raise your hand. Okay, so it's pretty good. So basically, there's no reason for all this. We can just basically go to the demo. Like, why would we do that? So the demo, you can see, relatively okay, right? Okay, cool. So this is the notebook. Okay. So this is basically a notebook, and when I mean notebook, it's like a REPL in your browser, right? So if you know what REPL is, raise your hand. Cool. For those of you that want to know what a REPL is, it's just like a program that reads something, then evaluates it, and then prints it out and loops, right? So it's supposed to be very interactive. That's why it's REPL. So this is the REPL in the browser. So you go to some kind of page, and then you get this REPL, and you put some queries in, and you get results super fast, right? It's pretty simple idea. So let's try this one over here. So I have like a simple imports over here, which I'm going to run. When I run it, it will show me that it succeeded, which is cool. I have some text over here, which we'll look at later. But what actually I want to show you now is this query that I'm doing. So this is like a SQL query, right? It's pretty simple. I'm doing this on BigQuery, which is Hadoop SQL engine. So let's actually try to run this one. So should be running. So it says running over here. It says 0%, and while it's running, I'm going to talk a little bit about like what. Okay, so it's almost like done. It's like 70%. Oh, it's done. Okay. Now I'm going to just explain what it means. So basically, we're selecting like two things. We're counting some volumes, which is actually a number of books that a specific term appears, which in this case is New York, right? For some reason, it's not really important why. But then we get this really nice result here in a form of graph, right? Makes it pretty easy to read. You get the year on the X and the number on the Y. It's pretty simple, but maybe let's search for something else. Can you come up with something that we can look for?
Warsaw.
Warsaw? I don't think there will be anything there. Well, let's try. So it's running, and it's 0%. Okay, 90. So it actually there was something. We got this. It's okay. I mean, it started around like this thing, which is like 100 something, 1800. It's relatively okay. But there's actually a reason why I'm showing this to you, and we're not going through the agenda. Because I have a follow-up question about this. So, how much data do you think we're crunching here? Like, if you were to come up with a number, is it 2 megs? Is it 10 megs? Is it petabytes? Is it terabytes? Is it gigabytes?
Gigabytes.
Gigabytes. Okay. How many gigabytes?
How about 10? Something like that.
10 gigabytes. There's one guess. More? I remember that it was like, you know, I pressed the enter and I couldn't even explain what the SQL was about, and the results were back. So think about that. Okay, so there was like 10. So it's actually 300 gigabytes that we're querying here. So that's actually fascinating, and it is fascinating definitely for me, because if you think about it for a while, it's 300 gigabytes that we're querying over here, and we're getting results back in seconds, right? Like, this is like really interactive feedback loop that we're getting here, and it's really mind-blowing. And this is like a true like outcome we're getting from people. Like, we're losing people because brains are melting basically.
How many nodes is inside?
How many nodes is inside? That's a good question. Actually, that is unknown. You cannot know that because it's under the hood by Google, right? But it's actually an interesting question, and we can talk about it afterwards, because it's actually not the way Hadoop works, which is interesting. But let's talk about it afterwards. So it's really interactive and mind-blowing experience that we're getting here, and I'm like super hyped about it. But before we all become like way too high, let's stop for a while. So, and let's take a deep breath and just think, like, how come we can do these things nowadays, and how awesome it is that we're living in this time that it is possible to do this kind of things. And to do that, let's do a review of what happened. Like, how come this is possible, right? So this is a very subjective review of history, and definitely not a complete one of how come we are here when it comes to notebooks. And this is relatively from the point of view of Google, because yeah, they did not come up with big data, but they definitely made it possible, and they create traction around it for the community to build tools and all kind of stuff. So Google was created in 1980. What was the use case? They wanted to create a search engine. What do you have to do? You have to download internets. If you have to download internets, you have to store them somewhere. You start storing them on disks, on regular disks. What happens next is that those disks will start failing, and they will start failing really bad. So you have to think, okay, we have to come up with some kind of system that we can store data in, and has to be distributed, because there's no way you're going to store all that data on a server. It has to be fault tolerant, because the disk will fail, and also has to have a high throughput, because you want to save lots of data, and you also have to read it back. And they came up with GFS, right? GFS, the paper was published in 2003. Fun fact about IPython, IPython was started in 2001. Makes it actually a pretty old project. We'll talk about it later. Then when they had the file system in place, they had to somehow process the data. They came up with MapReduce. By far was not the fastest system that they could come up with, but it was very generic, and they had lots of applications with it. Then they published both papers. Yahoo has kind of the same use case, so they were building this system called Nudge, and they saw these papers, and they were kind of jealous, so they just took it and implemented their own version. Thus you have Hadoop. 2005. Between 2005 and 2010, nothing really happened, but nothing related to straight to the point of notebooks. 2010, first release, public release of Spark from Matai, and that actually created a traction around interactive use case. Spark did not come up with interactive use case. It just made the community, made the traction around it. The community built so many tools, and now we have notebooks. And then notebooks, Zeppelin, 2013, and Jupyter Data Lab that we'll talk about later, 2015. So you can see there will be more. 2016 will probably be a year we're going to see even more of these. Hopefully, some of them will die too. We'll see. So this is relatively history. And then, as I said, Spark did not create the use case, but it created traction and created community around the interactive use case. And created it because Spark is better than MapReduce. If you assume certain subset of metrics, it is. If you assume that we're talking about speed and interactive use case, it is definitely better than MapReduce. And why is Spark actually better than MapReduce when it comes to speed? Ideas?
No HDFS.
No HDFS, that's one.
There's some data in memory.
Memory-centric, yeah. Okay, this is actually, we can stop there, because memory-centric is actually the point. So, before we actually go further, let's actually take a look at what MapReduce does and what Spark does and what makes Spark so fast. So in case of MapReduce, and you saw that before for sure, you have your input all the way up there, and then mappers, they will read the data and somehow will create records out of that data that you can later crunch somehow. And then mappers will store the data on the local disk, and then in the reduce phase, shuffle phase of the reduce phase, shufflers will get the data from the local disk, and then the reduce can somehow save, it can also spill to disk if needed. And after reduce, all the data goes to HDFS or whatever persistent file system you have. So lots of usage of disk over here, as you can see, and also does not support iterative use case. So every time you want to do another iteration of MapReduce, you have to go to HDFS or something and then read it back again and again. When it comes to Spark, it's a little bit different. You read the data in, you try to keep everything in memory as much as possible. You can do iterations over the data. The data is supposed to be in memory. If it cannot keep the data in memory, it will spill to disk, but it will try really hard to keep everything in memory. So it kind of makes sense that memory is faster than disk, right? And everyone says that, but like how fast it is, and how much faster is it, I guess. So in this table, and I hope you can see the first column is the resource or operation. The second column is latency of that resource or operation, and then the third column will be scaled value. And what I mean by that is, let's take a look at L1 cache reference. So if you want to reference something in an L1 cache, it will take you 3 clock cycles, which is we can assume that it's 1 nanosecond, right? I have no clue what is 1 nanosecond. That means nothing to me. So let's assume that 1 nanosecond is 1 second, right? We kind of know what is 1 second. It's kind of like this. It's 1 second, right? So let's see what happens when we scale these values. So if you go to the main memory, which is third row, 120 nanoseconds. That's 2 minutes, right? So instead of 1 second going to L1 cache, you're doing 2 minutes. If you need to go to SSD, that will be 23 hours. So SSD, the super fast disk that you can get, it's going to be still 23 hours. If you compare that to the memory, 2 minutes versus 23 hours. If you happen to still have this old disk that will rotate, then you have to wait 64 days instead of 2 minutes versus memory. That's for I/O, but you first have to go to the place where you want to read the data, meaning you have to do SIG, and that's going to take 128 days if we scale the values. So you can kind of see from this table that it's really much faster to go to memory instead of going, even if you have SSDs, that's still a huge difference. Big difference. So that's basically why Spark is so fast. And also, just to mention a couple of things that recently happened in Spark community that made it even faster. Still memory-centric, so we'll still try to keep everything in memory. It will spill to disk if needed, though. Then they're working on a direct memory management, which basically means that they will manage the memory by themselves. So they don't wait for JVM to get the memory for example, for strings. If the string object is very short, for example, you don't need the whole memory that JVM will give you. They will make it much shorter. So that's the direct memory management. They want to leverage CPU caches. So these were the L1, L2, and L3 that is not in the table. If you see the difference between main memory 2 minutes and a couple of seconds for the L1, L2, L3, you can see another advantage of, like, you know, they can do this hop, they can do another jump in performance if they start using caches. Well, and that's Project Tangstone. Then also they are pushing data frames really hard, which is great because from there they can start generating code, optimized code. Right now they're creating optimized JVM code, but nothing stops them from, for example, generating native code, which will be even faster. Another thing that they're not really fixing at this point is if you have broken data or broken code, it will not fix it for you. So if you're, for example, doing group by key, Spark will do nothing about it. It's just you have to change your code because that is just really not great for performance if you use that function, API, I guess. So that's why Spark is so fast, and that's what they're doing right now to make it even faster, meaning to make it more interactive. With that, now we know that how Spark is so fast. Let's take a look at what is the use case. What is the use case of notebooks and why people want to use it. The first one that I have is the quick ad hoc and interactive analytics. What it means is that people want to dive into the data, look around, like see what's in the data, how data looks like. Maybe they will find something pretty quick, and then afterwards they maybe will create some production pipeline. But first they want to just see what's going on with the data inside, and that's the interactive use case for it. The second one is Glue infrastructure. As it turns out, most of these notebooks, they support different engines. So you can connect, for example, Hive, you can connect BigQuery and Spark and Flink in one single experience, meaning you don't have to support all of them in a different way. You can have one holistic overview of what are the tools that you can use. The third one is human readable big data. So something that is also getting more and more traction right now is storytelling, where when you come up with results for your data, you want to tell a story about it, right? You want to say like, okay, this is the data that I came up with, and then my reasoning, my thinking is like this, and then you show different graphs, then you show different data, and then you show your results, and people can understand. People that don't even understand technology can understand what you're doing in your notebook. So that's another use case, and we'll talk about it more. The fourth one is collaboration. Notebooks are pretty good at collaboration. You can share notebooks with other people, you can work on the notebooks together, which we'll look at soon. Notebooks are great at it, much better than, for example, some kind of libraries or just coding or pair programming. So these are the use cases. Any questions to the use cases? No. So if we know the use cases and we know why Spark is so fast and why it enabled us to have notebooks, let's take a look at the options that we have right now. And we're going to talk briefly about 4 of them, and then we're going to do demo with one. So first one is the Apache Zeppelin, then we're going to talk about Jupyter, Data Lab, Databricks, and Spark Notebook. Anyone who used Spark Notebook maybe? Raise your hand. Cool. So these are the options. The first option is Apache Zeppelin. Apache Zeppelin is Apache incubator project started by NF Labs from South Korea. It's open source Apache. A couple of things that is unique for Apache Zeppelin is that it has a pretty good support for scheduling. I mean, it's actually there, which is good. Sharing data between interpreters is another thing. Graphing is possible, but it's not really the best experience that you can get out of notebooks. Also, it's not very mature. It's pretty new project, so you have to expect glitches here and there. You have to fix stuff by yourself. But it has on-premise support, which is cool, for example, for us, because we already have clusters, so we can just connect it to it and just use it. What are the engines that it supports? It supports Spark, Flink, BigQuery, and a couple more. Languages, mostly Scala. So if you are into Scala and if you want to use lots of Scala APIs, then Apache Zeppelin is probably what you want, because that's a notebook that is kind of focusing on that language. Then you can also use SQL, Python, and a couple more. We'll see that later. Jupyter. Jupyter was decoupled from IPython. So the project that was started in 2001. So it's pretty mature. There's pretty good community around it, and they create lots of libraries, integrations. Like for example, you can integrate it with GitHub, you can integrate it with IntelliJ. So that's nice. It's nice to have good community. There's good support for version control, which is important. That's going to be the first problem that you're going to have when you have notebooks. First thing, you're going to install it, then it's going to be so cool, everyone's going to be so happy, and then there's going to be a question, how do I go back to my changes 2 days ago, because I need them back. So Jupyter, really good support for that. Language agnostic, IPython notebook, supported engines. It's mostly Spark and MapReduce, but there's a way to configure it in a different ways. Languages, lots of languages, but mostly Python. There's R, there's Scala, and a couple more. Datalab is basically Jupyter fork supported by Google. So if you take Jupyter and basically integrate it really well with Google data platform, cloud platform, you're gonna get Datalab. It's still open source, which is nice that I did that. The main engine for them is BigQuery, which is very nifty because BigQuery is pretty stable. They give you support for it, and it returns results really, really fast. It's much faster than Spark and anything you're gonna get. So useful for that. If you already use Google Cloud, you probably want to do Datalab. Supported languages, Python and SQL. They're thinking about Scala, but we'll see. Databricks, any customers of Databricks? Anyone use Databricks Cloud? So Databricks Cloud Databricks, by the way, is a company behind Spark. So these are the people that created Spark, most of them, and they're kind of supporting this tool. It's a commercial tool, closed source. They have good support for Spark, mainly because they created it. And also, if you have money and you just don't know what to do with it, I guess this is like a good candidate. It's called Databricks. On-premise support. Someone said, I've heard that it's coming. It's coming because they dropped the cloud. So it used to be Databricks Cloud, now it's only Databricks. And they kind of mentioned it on the summit, Hadoop summit. So we'll see if you have on-premise cluster and you want to use Databricks, maybe you're going to be able to do that. It's good support for pipelines and job scheduling. That's also pretty useful. Supported languages, there's Scala obviously, SQL, Python, R, so everything that they support. An engine is Spark, yeah.
So the tool is called like the company?
Yeah.
That's fine.
It used to be Databricks Cloud, so that's basically the options that you have.
Apache Q. One more, Apache Q.
Apache Q? No, we're talking about the ones that actually are useful. What about that?
There it is an option.
Kicker. No.
But actually you had on your slides Spark Notebook, right? You had on your slides.
I had on my slides, but we're not going to go through them.
I don't know.
But Spark Notebook it has good features. It has a community, but it seems like most people are talking about these two, and most people are using these two, right? There's more community definitely behind this thing. This thing is getting more and more community, and it's getting funding. So it seems like Spark Notebook is out there, but it doesn't seem like it's going to be that big of a thing.
The big thing is that it integrates with HUG, right?
If you use HUG, that could be a big thing for you. Yeah.
There's a lot of companies using. No? Not you.
Like for example, no, I'm talking from my own experience right now. So yeah, like if you're a Cloudera customer, you probably that's a good thing to use HUG. But they're kind of trying to like over-engineer everything in there, and like we're not using it. But if it's a good thing for you, if you already use HUG, then maybe Spark Notebook is a good thing for you, right? I mean, in this presentation, I'm not going to tell you, basically, I'm not going to tell you use this or use that. I kind of want to just bring up a couple of a couple of tools that you can use. And all of them actually do kind of the same thing. One or two maybe have different features, but the core is kind of the same for everyone. So, like, at the end of the day, if you want to use the shiniest, the coolest, the most open source tool, you're probably going to go with like Zeppelin or something like that. If you care about community and you want to be safer, you're probably going to go with Jupyter. If you want to use HUG, you probably want to go with the Spark notebook. If you are a customer of Google, you probably want to use Datalab. Databricks, you probably want to use Databricks. All of them do stuff in an interactive way. All of them do graphing in one way or another, maybe simpler, maybe not. You can always build these libraries on top of, like, for example, Apache Zeppelin makes it easy to start graphing because it's not there out of the box. But it's more about like going through what you need and what you already have at your company, right? If you have HUG and you really like it, Spark Notebook is the thing, right? So with that, we are actually at the real demo now, part of it. So, last time we finished at this point, but now let's do the actual demo. So, everyone can see, I'm going to try to zoom in to something that is important every now and then. So when you have your Zeppelin cluster for the first time, this is going to be the first view that you're going to see. This is the main page, right? And the thing that you want to look for is this thing on the top right over here, connected. When it says disconnected and it's red, it's not good.
Probably you are not connected.
That's kind of true. It's not. And I actually had this. I had an issue right before the presentation with that thing.
Query, right? Whenever you are disconnected, you can run your query, right?
Yeah. So yeah, just like, look for connected. Then you have a welcome to Zeppelin. You have a list of your notebooks over here. By default, you're gonna go to your local file system. They have support for S3. It's pretty easy to add support for HDFS or Google Cloud Storage or anything like that. They have a couple of methods like save or update your notebook. That's all. You can implement it. It's open source, so you can contribute it back. So I have my notebooks over here. I can select them. I can also create a new notebook, which I'm going to do. So I'm going to create a notebook like this, and then I'm going to wait a little bit, and my notebook should show up somewhere here. And it takes a while because I have support for HDFS, so it has to save itself to HDFS, which takes a while in the end. But I have my notebook over here now, so I can click on it. And then when I click on it, I get my notebook. This is the title of the notebook. Then I have a couple of controls over here. I can run all the nodes, also called cells, which are this. Excuse me. Oh yeah. So this was the title, but the title is perfect, so I'm going to keep it. Then I have this control over here to run all the nodes. I can hide all the code if I want to, hide or show. I can hide or show all the output, which we'll talk about soon. I can remove the notebook, and I can clone the notebook. I can also schedule the notebook, which is like a cron syntax, and then Zeppelin server will run the notebook every time you want. So this is what I get here. Then I have some information, I have some settings, and also have I can choose the way I want to display my notebook, which we're going to see in the end. So that's one thing. I can also select my notebooks over here, which is another thing. And then I have my interpreters over here, which is basically like a list of different interpreters / engines that we can use in this notebook, and you can add more per notebook, and we'll look at them very soon. So it also says that this thing Spark is the default one, which is kind of important. But let's actually try some interpreters first. So I'm going to open previous notebook. Oh, by the way, you can see that disconnected. Oh, now it's connected. No, it's too late.
Zoom helps.
I'm going to open the demo and we're going to go through the steps. So this was the first. First thing that we did previously, which was to do some imports, right? So if I just put something in this node, also known as cell, and I press Shift Enter, it's going to execute that cell, right? But what is it in this cell? In this case, it's a bunch of imports that I'm doing. So if I don't specify what is the engine or what is the interpreter, it's going to assume it's Spark / it's Scala, right? So this is like a Scala import that I'm doing here, and I'm getting result that says, import this and that, which is the outcome, and it's successful, which is great. So let's take another one that we have over here. So we had our big query from the very beginning, and now we have another one over here. So there's another interpreter over here. So what I'm doing here is I'm saying percentage MD. So this is another interpreter, and this is a markdown interpreter. So if I put a markdown code over here and I press Shift Enter, I'm going to get the result, right? And this is a markdown result for it. So I can demo. This is the blah blah. So I can do this markdown. There's a couple of other interpreters that I can use that we can look at right now. So there's a Spark interpreter, there's Python Spark interpreter, SQL, dependency, and there's BigQuery. Every interpreter can have some kind of properties. So for example, for Spark, you probably want to set the master. So where's your master? There's a couple of other values there. There's MD, so markdown. There's Angular that we're going to look at very soon. So basically, if you use this interpreter, the code will be rendered by Angular. Then there's SH, which is shell on your master, and that's basically all. So what it means is that we basically can for example, put a shell here, and we can do ls of our root. And when it returns, we're going to get the ls of the root, right? Pretty much what you expect. Then you can actually, for example, save that to some kind of value. If you want to do something, you can cut some kind of file. If you have that in your file system, you get the point, right? So that's one thing. But let's go with the demo. So let's assume that you're working for a bank, right? You're working for a bank, and let's assume you wanna find a target group for a loan that you wanna basically go and sell to people, right? And you go to your coworker / your boss, and you can ask that person, like, how do I even start with this, right? I don't know where's the data for this, and your boss or colleague says, like, okay, we have this data set over here, and it's a comma-separated value file. You can get it, and there's lots of data in there, and you're definitely going to find your data there, answers to your questions for sure. So what you know is that there's this data set here, and it's on S3, so that's how you start, right? So basically what the notebook experience, in this case Zeppelin, can let you do is can let you do some kind of ETL. So right now we know that this data is there. So let's try to extract that data. And this is a cell that will help us do that. So in this case, we're doing some kind of import of some classes that we need. And then what we're going to do, we're going to get that comma-separated value. We're going to split it. We're going to put it into a string, split it by new line, and parallelize it, meaning we're going to get RDD over here, right? So bank text is in RDD. Then, okay, so I have my data locally. So I want to look into that data and see what the data looks like, right? Because I want to work with it, so I need to know what the data is like. So I'm going to do bank text. I'm going to take 10 rows out of it, and for each of the row, I'm going to print it, right? So pretty simple, and then I see my results over here. So these are the imports. This is my RDD that was created, and these are the prints, right? So what I can see is that, okay, so the first row seems like it's a header, right? It says what is the data about, so it says age, job, some kind of marital status, education, blah, 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 balance. So yeah, so I kind of get what the data looks like right now. Maybe I should somehow put it, so I kind of like extracted it right now, maybe transform it a little bit. I need to be able to load it so I can then play with that data. So how do we then load that data? Well, we still have to massage it a little bit, which we're going to do with this little cell over here. So in this case, I assume that the data that I need in this case is going to be the age, your job, your status, your education, and your balance, right? I don't care about any other data from that data set, meaning I can create a case class over here that will help me to work with the data. So I create this case class over here, and then based on that case class, I'm going to transform the data to the data frame. So what I'm doing is I'm splitting the data by the semicolon. I'm going to get rid of the header. So I'm going to see, okay, if the row starts with age, meaning it's the header, just skip that row, right? Then I'm going to actually create the objects for the case class over here, and I get the result and I put it in the data frame over here, right? And then when I have my data frame, I can load it, meaning I can register it as a table, as a SQL table, and I'm going to call it bank. So now I have my data extracted, I have my data transformed, and I have my data loaded in, right? Now I can start playing with the data. So what can I do with that data? The first thing that we can do is we can basically take and select everything and see what we can get from that data. So in this query over here, we're selecting everything from this bank table. We're getting everyone that's less than 100 years old, and we're going to limit the result to 1,000, right? And when you do that, when I execute this, I get this results over here. So I get this this table that says age, job, and all that kind of stuff over here. But that doesn't really help me much because it's still a table and I cannot really read tables. Fortunately for me, Zeppelin comes with predefined charts. So I can, for example, use the bar chart. And I'm going to get this result over here. Okay, so I'm getting this result over here, which gives me a chart with, in this case, number of years old, and also your job, meaning I'm not sure what the job will mean here, so let's look at the settings. So in this case, Zeppelin decided to do a sum over your jobs, which I'm not sure what it means, so I'm just going to remove this. But I want to look at your age and I want to look at your balance, right? So let's put the balance in, and then you can see this little thing, sum here. So it means basically that it's going to sum the stuff per x. So yeah, I like the sum. So I'm going to keep the sum here, and then I can see a little more meaningful data here. So I have the years, I have your years old, your age, and then your balance over here. So you can see that if you're 20 something, you're probably you don't have that much money. Then when you're getting older, you get more money. Around 30 something, you have the most amount of money that you can get. And then when you're like 40, you probably have to pay for your kids' college or something like that. And then when you're like 60, then you just like don't care at all, and you just basically just spend the whole money that you have, and you have nothing. Which is cool, but like, okay, I'm kind of curious, like why, like what's going on here. Let's see what other data we can get out of this. So we have your marital status. So maybe let's put that as a group over here, right? So now we're gonna get the age, the balance that you get, and also it's gonna be grouped by your status, right? So you can see over here that you can be single, married, or divorced, right? And when you look at this, like there's not so many people divorced when they're 20-something. There's something going on around 27th year. But if you start looking at the 30-something, then it starts, you know, then people start getting divorced like really badly. And also, when you look at the balance of those people, they're pretty, they're not rich. So if you plan to get divorced, then you have to keep that in mind, that you're going to lose some money, at least based on data. So people are getting divorced over time, but at the same time, when you are married actually, people are also pretty wealthy. But if you're single, you're going to get more money anyway. So, not suggesting anything, but definitely not, do not get divorced, because that doesn't work at all. So, you know, you kind of see this right now. You see that, okay, maybe we should target people that are around 30-something, because they're probably going to get divorced and they're going to need money. So that could be a good hint. Then we can look at other charts too. You can get like a pie chart over here. You can get an area chart. You can get a line chart. You can even get a scatter chart out of this, which can be cool if you want to show it to your boss and get more data into this. Which when you get the settings, you can actually get some meaningful stuff in here. So if I, for example, if the Y is the job, so I get the job, for example, student over here, I get the age on the X. I can make the size of the bubble. For example, I can make it your balance, and I can still group it by your status, right? So now I get lots of data on this graph. I get your age, I get what you're due, and I also kind of see what's your status, whether you're divorced, whether you're single, whether you're married, and I also kind of see your balance, so like how wealthy you are on the same graph, which can be pretty cool to see some kind of hidden data, hidden hints in your data. For example, like students, like again, not so much money, but also not married. So good for them. So you can get all these kind of graphs, and you can kind of show it in this nice way. People can go through those cells and kind of read the data by themselves, kind of read the story of the data. But then the next thing that you're gonna get is this person that's gonna ask you, okay, why 100 years or something like that. You're gonna be like, I'm mostly interested in 50 years or like less than 50 years, right? So then what you're gonna do is you're gonna change this value, right? And you're gonna put 50 here. And you're gonna run it again, and you're gonna get new data. Fortunately, it's gonna return pretty fast. But next thing you know, next day someone comes and they're like, okay, but now we're kind of more interested in less than 30, right? Or maybe it's less than 30 and maybe it's less than 50, and age is more than 30. Then you're gonna change it again. So you get the point. You have to change that a lot for like a common pivots of your queries. Fortunately, Zeppelin comes with dynamic forms, which we're going to look at right now. So you can create a query, and then you can parameterize that query. Like for example, in this case, and I will zoom in. It's basically kind of similar query, but this time I'm going to select age and I'm going to count the values, count the rows. But then I put this weird thing over here, which is like $1 and then bracket, and I say age and 35, right? So what's going to happen is that I'm going to get this result, but also this form over here, right? This form that says age. So by default, it's going to be this 35, right? But if someone wants to change it and say, for example, 50, they can put this value 50 here, and they will just get the new result. That is up to 50 when it comes to age, which is pretty cool. Which can be cool for, especially for people that don't understand SQL queries or anything about code. They can just change these forms, and it's pretty easy to do that. Also, it's good when you want to tell the story and someone asks a question. You don't have to go to the code. You can change that in this nice form. You can kind of think forward about it. And when you also want to create your reports, you probably want to structure it in a way. So Zeppelin comes with, you can basically change the width of the cells. So let's say I want to make it a half screen for this one and half screen for another one over here. And I can put these two next to each other. If it makes sense for me, if it makes the presentation better, I can do that. And I can also get this form over here. Another thing that could be useful for this data, for example, would be to make a dynamic form, but with limited number of values that you can put in. And you can just take the SQL query again, but with slightly different syntax. So we can do this. And so you're going to do the same thing from, but then for the status, you're going to say $, and then you're going to list what are the values that are possible, also the default one, right? And I get result over here, and I can also graph it, all that kind of stuff that you can go with the other, through all the other queries. But then you can also select a different status over here with predefined values, right?
Is it correct? Married.
Excuse me?
Double A in married.
Okay. Then I'm interested in what we're gonna get. Oh, so now we get no data available, which makes sense. So we can fix it. So now we can fix the data. So I removed it. Now it's single, and then we get the data. So that's another thing. But then the next thing that's going to happen is that you get all these nice graphs, but then you have to create this really weird graph that someone really wants, but that graph is not available in this set of predefined graphs, right? If you were using Jupyter, then in Jupyter you can easily do that. You can use all the Python libraries, all that kind of stuff really easily. It's basically how you graph it. With Zeppelin, you kind of have to go through some steps. So in this case, I'm gonna do some magic numbers here that you can kind of ignore because you have to set up your Python to do this. But what we're gonna do is we're gonna basically use another interpreter that Zeppelin comes with. Zeppelin comes with HTML interpreter, meaning you can put any HTML in or JavaScript there, and then it's going to interpret that and show the result, right? So we're going to use that together with Python libraries. You can use Python also if you use PySpark. So PySpark is another interpreter that you can use. If you use that one, you can just use Python, and you can use Python libraries. So now we have this helper method defined, and we can use PySpark.
Sorry, are you going to share out this notebook later on?
Yeah, I can share it.
Okay.
So what's going to happen now is, basically maybe let's take a really quick look at this method over here, because it's interesting. So in this method we're going to get a plot from a Python library. Then we need some kind of string to basically just dump the data. And then we get the graph and we save it as SVG. Then we go to the beginning, and then we print this thing, which is we say percentage HTML, and then we put the div. This is the regular HTML thingy, and then we say yeah, and then we just basically push the whole SVG over there, right? Makes sense. Then in this case, this is just like this pure example is like a random graph, nothing really serious going on here. But in the end, what you get is you get a nice graph, right? So you can imagine that you can use, you know, your libraries from Python. You probably want to put this like kind of this helper method somewhere. You don't want to like always redefine it, but like you can imagine just put it in your library, or like someone should probably push it back to Zeppelin or something. But you can kind of do this kind of stuff. Whatever graphs you can come up with Python libraries, you can just push it here, which is also another interesting thing of using this HTML interpreter. So as you can see, you can basically put like percentage and the name of the interpreter. It can be all the interpreters that you have defined, and then anything that comes after it gets the interpreter. Whether it's going to be printed by Scala, it doesn't really matter. If the dollar is there in the output, it's going to be reinterpreted by the interpreter that is there, right? Then the next question is probably, okay, so I get my results from my super cool Scala library, and then I want to graph it, but I don't want to graph it with this weird simple graphs. I want to graph it with this really cool Python library, right? So how do you connect these things together? Turns out that's another cool thing about Zeppelin. You can not bind, but you can share the data between different interpreters, right? And to do that, you have to use a special variable called Z for Zeppelin. And let's take a look at the example for that one. So I have it ready over here. In case this is actually combined together, so we're going to look at both sharing data and Angular at the same time. Pretty exciting. Anyway, Angular, I'm going to say, you know, the header, hello, and some kind of variable name, right? So what I get is I get hello and nothing, right? Because in Angular, I didn't bind anything to this variable name, right? Turns out I can do that later on if I just say, if I use this magic Z variable and I use Angular bind and I say, you know, this variable name is this value, and I say, I can for example say name is bind to, it should be this. And then, yeah, we're kind of lucky we actually get it here. So you can kind of see that you can connect these values together. You can connect, you can share data between interpreters. So if you get a result, for example, let's say I get a list of some predefined values from some REST API. I get it to some kind of variable in Scala. Then I put it in Z to share it with Python or something like that. Then I put it in SQL context to say that this form should have this predefined values, for example. You can do this kind of stuff, which is pretty exciting and can be useful. And that is actually the end of the demo with the features of Apache Zeppelin. And we are hiring, actually. So if you would like to do this kind of stuff, or if you would like to work with Hadoop and big data and one of the biggest clusters in Europe, we are really hiring. And an interesting fact is that I was actually hired through Meetup in Krakow. So I think meetups are really great if you're looking for something new, if you're looking for cool, exciting, and challenging jobs. You can totally talk to me, or you can talk to Johannes. He's waving over there. You should probably talk to him, because here he's more talkative. But anyway, we're hiring. That's a surprise. And I'm kind of ready for questions now. You can also reach out to me on this Twitter user name, and I need more followers because I'm missing a bet with my friend on the number of followers, so you can help me out. Or you can also reach out to me on this email, which is like rab@spotify. You can do either, and you can ask me any questions. You can reach out to me when it comes to hiring, anything. Anyway, questions.
Do you have any layer of authorization before the Zeppelin? Because for the Jupyter, there is Jupyter Hub. And do you have something like that for the Zeppelin?
There's Zeppelin Hub, that was built by the same company, NF Labs. So you can use that one. This is basically experiments. Like, this is not supported at Spotify. This is just like one person playing with this and trying it out, and that's all. Like, so if we were to actually use it at Spotify, yes, we'll probably need something like a good security and also like multi-tenancy in that case.
So what do you want? What do you use? Which one? Jupyter? Which of those notebooks?
Oh yeah, so we're mostly using trying out Apache Zeppelin. But we really don't know which one's going to be better, especially when it comes to, so we have two options, like when it comes to us. It's going to be either Jupyter or it's going to be Zeppelin. Yeah, at least this is what we want to use. We, for example, don't use HUG, so it's not a thing for us where the support for HUG. So we're not sure which one's going to be better in the end. But also we have time to choose. We're going to see, like, if people like, there's actually people that are using both Jupyter and Zeppelin, but they support it by themselves. So what we are basically doing is we wait for one to die out, and then we're going to know which one won, and then we can support that one. Probably, not sure. Does it answer your question?
Yeah.
And also the question was what kind of layer of authorization we use for Apache Zeppelin, and yeah, you've heard the answer. Any more questions? Yeah.
So did you fight already with the problem of multi-tenancy? I mean that multiple users use the same Zeppelin instance? The problem is, that I experienced, that all the users are actually sharing the same session. So they have the same variables, the same context. That's pretty, I mean, that makes Zeppelin unusable for larger scale, for more than one person. That's not that hard.
The thing with we actually like about that sharing part and collaboration is that you can actually work on the same notebook and you'll see this live updates, right? And you can fix each other's code. And it's usually that there's more experienced person somewhere there just watching what's going on in your notebook and trying to, like, if there's something really bad going on, you can like unblock the person, but you're not going to change that code. Like, you know, you're not going to, if you want to be mean to a person, you can like find so many ways. And the notebooks are not going to be the worst thing you can do. But also, the thing that we want to kind of do, and we're not doing that, would be a different use case where when you want to use a Zeppelin, you get your own Zeppelin instance, right? And it's yours to keep, right? And then if you want to share your notebook, you will share it somewhere. Maybe it's going to be a thing like Zeppelin Hub, right? And then another person can download that Zeppelin notebook and can play with that notebook by themselves. If they actually want to share it in a way that is like dynamic and live update, they can still do that, but it's their choice. Then they choose to do that, right?
I mean, that will be provided the solution for now, because it's good when if you share context, share environment in the same notebook. But the problem with Zeppelin is that you share the same context across notebooks. That's totally unacceptable, right?
Yep.
When you go to the next notebook, you will think, hey, I should have like completely separate environment.
No, but in our case, we're basically doing separate Zeppelin. You get separate Zeppelin just for yourself.
But that's also something very unusual to start web application per user, right? Usually you have a single web application across company, and a lot of users use it.
I mean, in the end, you probably... So another tool that they came up with was Z Manager, I think, where it's basically like a proxy that allows you to create this Zeppelin clusters, and then it proxies you to your clusters. So that's basically the use case that they solved, and they have a presentation. I think the main guy, the CTO or something, he basically says, okay, like we went to customers of ours, and we saw that they need this kind of thing where they have to have separate clusters. That's why we created Z Manager. So that basically seems like that's the way they want to go. So, by you know, at least now.
It's probably that will be solved, because that's the biggest obstacle, I would say, to go into production. And the thing is that Z Manager might be a solution here. It's not yet, because Z Manager requires you to use Spark standalone. You cannot use Spark on YARN when you use the Z Manager. But probably they will solve it.
Yeah. But also, we actually tried a little bit to build some kind of tool on top of Zeppelin that you can start your own clusters. And it's, at the end, I mean, it's like relatively simple thing to do. It's, and then another thing that we kind of hit was, okay, so like how do you share these notebooks? Like where do you keep them? How do you version control, this kind of stuff? So I would say like creating your separate cluster was definitely not like, but that's basically how we're solving it. We're creating separate clusters for users, this right now. But then it's not really a supported tool, so we'll see. If we come up with something different, then.
What's the use case for this at Spotify? Like who's going to be the customer?
I mean, the use cases are basically what we were talking about earlier. These are basically the use cases. So the ad hoc, when someone wants to just like dive into data, see what's going on in there. Dashboarding is pretty big because you can integrate all these different tools and just get it in one single place, and you can get relatively okay graphing. So people use that for that. These are the two main use cases.
Data scientists and like DevOps. Those are the two people.
Yeah. But also, that sums it up. Yeah. And the question was, what's the use case at Spotify? I should repeat the questions first and then answer them, probably. Lessons learned. More questions?
Why not use like a commercial tool, BI tool? Why go with Zeppelin?
Which BI tool would you use?
Datawatch maybe?
The reason why we want to use Zeppelin specifically in this case is the support for Scala, and the fact that we can use Spark, which we cannot support that well with our YARN cluster. We want to use Spark libraries, and we want to use Scala as much as possible. We don't really want to give it to anyone, like a kind of BI tool user. We want to give it to engineers and data scientists that know how to use Scala and know how to use Spark, and we find it to be a good environment for them. And they don't really want to use BI tools. The BI users will probably stay with the tools that they already have at Spotify, and they're completely fine with them. So this is not for them, definitely. It's more for the Scala users, more for data science, more for Spark, more for that libraries. Yeah. Did I repeat the question? No. So the question was, why not use BI tools that are already out there and are, you can pay for them and they're well supported. Are there any more questions?
I have a question, but it's unrelated to data notebook. It's about music recommendation in Spotify. I have found in the internet that you use Spark and Spark's version of collaborative filtering. Is it true? Do you have your own implementation of some algorithms, or are your recommendations based mainly on Spark MLB algorithms?
It's a good question. Do we have our own implementations of algorithms? I believe so, and you can Google Chris Johnson. He has a white paper about recommendations at Spotify, and he's basically describing what we are using for recommendations. And he's a person that is basically responsible for the team that does that. So that's one paper you can check out. There are also articles about Discover Weekly, There's a couple of technical details in there too. It also says a little bit about algorithms that we use there. There's Quora. There's a question about that too there. So I guess the answer is yes, we have our own implementations, and also we're using Spark libraries. And also there's a couple of playlists that you can check out. There's actually a couple of videos on YouTube too from that teams that you can check out, and they talk in details about that. Yeah. More questions? No? Cool. Okay. By the way, if you want to go if you want to talk more about Spark, Hadoop, or anything like that, we can maybe go for some kind of beer or something like that. If you're into that, we can create a bigger group and go. But this is basically the end. Thank you.